Welcome back to PLS 510. Today we're going to finish up the section on pasture management, and this section we're going to focus in on rotational grazing in particular. So let's get started, because in starting off, we know that rotation is going to be the way that we foster proper forage growth and get it utilized by grazing livestock. First, I want to go over a few terms. AUM is animal unit month, and then we're going to talk about stocking rate and stocking density. The animal unit month is the amount of forage needed to support a 1,000-pound cow and calf for 30 days a month, which is about 900 pounds of dry matter, or 90% of their body weight per month. And so that's the base definition of animal unit months. Of course, in your exercise that you did in class, you adjusted your animal unit months from the web soil survey based on the weight of the livestock you were going to graze. The next two definitions have to do with the stocking rate or stocking density. First, we'll talk about stocking rate. Stocking rate is the number of animals per total pasture land for a given period. And we typically think of it for that period being the full season stocking rate, and that's called carrying capacity. Now, it's easy to get confused with something called stocking density. This is the ratio of animals to land at a given moment on the paddock they are grazing. So think of it as a snapshot in time that uses only the land base that the cattle are on at that point in time. In other words, instantaneous. For example, if you have 40 cows weighing 1,400 pounds on a 1/2 acre strip, that winds up being 112,000 pounds per acre stocking density. Very much something that would be in the mob stocking density category. And you find this term used when people are talking about using high numbers of livestock for very short durations on a piece of land for a given purpose. That purpose may be to have extremely high levels of utilization, to take completely away the selectivity that animals might have for the forage that is present. So that is stocking rate versus stocking density. Obviously, stocking rates are much more are lower usually than the stocking density of the moment when you have a subdivided pasture system. So the keys to an efficient pasture system are going to be fence and water. We're going to spend the rest of our lecture talking about a subdivided pasture system and also shortening the distance to water, getting it less than 800 feet, and make a point or two about that. So as a way of backing up just a little bit and reminding you of what we've already talked about, with pasture management, it's not what you take, it's what you leave. This is a table from your Southern Forage textbook of some of the major forages that we might use. Particularly take a look at alfalfa, bluegrass, orchard grass, and so on. And we've got estimated or recommended starting heights and stopping heights, and how many days of rest that we need to give it. And we want to pay close attention to that. How is that height there at the end? We call that the residual height. That residual height is taller for the more erect species like grass species like switchgrass, the native grass, and pearl millet, that summer annual. It's lower somewhat for the cool season species, but even among those we're different. Bluegrass can be and should be grazed a little shorter than tall fescue, and tall fescue should be grazed shorter, can be grazed shorter than orchard grass. And remember, we said orchard grass needs more grazing height left after grazing or after cutting in order to persist well. If we're grazing alfalfa down to 2 or 4 inches, it's not so much for the alfalfa plant because once you get down past about 5 or 6 inches, there are no more leaves down there to drive regrowth on alfalfa. That 2 to 4 inches stopping height is because that's going to be almost all stem. It's going to be unpalatable, and to make animals graze below that is going to cost you production in making them consume that much forage. So with alfalfa, that it's not necessarily the same as a cutting height regime because we don't necessarily, well, we don't need them to take forage down that low because of impacts on performance. So if rotation is good, how many subdivisions do I need? This is a very simple formula, and you might run across it many times, but the number of paddocks that you need is based on the number of days of rest divided by the days of grazing plus 1. So let's do some calculations. And let's think of a few of our basics. Forage growth tends to happen on 30-day cycles. And back at the couple of slides ago, you saw the rotation period, and 30 days was in that range for most of those forages. After 7 days, livestock tend to regraze the same areas. So we want to keep our grazing periods at 7 days or less. And another reason for a 7-day rotation is think how often you're going to be able to rotate pastures. And weekly is at least a reasonable frequency. If you're close to the farm and you're there a lot and you have the time, more frequent rotations can be possible, of course. So back to our formula, paddock number is days of grazing, 30, divided by days of rest, which is 7, which turns out to be about 4, plus 1. So we need 5 paddocks to provide 30 days of grazing and 7 days of rest. Another way to think of paddock number, or the number of subdivisions, at least to make you understand that just going up into having more and more subdivisions is not necessarily that beneficial. Look at the percent rest of that pasture based on the number of paddocks. If you only have one paddock, in other words, no subdivisions, there is no rest. The whole pasture gets utilized all the time. Now, it may not get utilized well, but it gets utilized all the time. If you have 2 paddocks, you've at least got the potential to rest half of the pasture at a time. And you can see the pattern developing. If you've got 3, you can have 2/3 rest, or 67%. You got 4, 75% rest. You got 5, that's 80% rest. An interesting thing happens past about 5 or 6, and that is the percent rest that you're able to achieve by adding more subdivisions. The subdivisions does not go up appreciably. So you've captured most of the rest you're going to have by having 5 or 6 subdivisions. Beyond 5 or 6, and you may need them, it's going to be so you can manage the forage and maintain residual heights, or it's to do something on your farm or on the farm you're trying to manage that is needed. So just remember that the number of subdivisions doesn't have to be huge in order to be effective. As long as we're thinking about, intensifying a system, I want to remind you of something that we have talked about, and that is the sacrifice paddock. At least we mentioned it in class. What is a sacrifice paddock, and why do you need one? Well, first of all, a sacrifice paddock, like the name suggests, is a paddock that you can go to and not worry about overgrazing. In other words, it's intended to be punished. It is going to be kind of a escape hatch, if you will, or a safety net for a system. Because as you intensify a system and you begin to have more and more animals, or you're just pushing it a little harder, it is not a given that your year will be normal, and so you will need one. So let's think about some reasons, and I'll give you about a minute to think about reasons you may need a sacrifice paddock. I should be playing the Jeopardy theme for you so you'll know how long a minute is. Well, let's take a look at a couple that I thought of. You need a sacrifice paddock to maintain residual heights or prevent overgrazing when the forage growth slows down and there's not enough then for the livestock you're trying to take care of. It also prevents pugging or poking or destroying, the structure of the soil during overly wet weather. And no doubt you probably thought of other ones as well. So I wanted to talk about a few more definitions, and I put this page in here just to remind you that your forage crop pocket guide is going to have many, many definitions and is quite useful. This one happens to be table 29, and you can see the listing there. But let's take a look at some of these grazing systems and talk through them. This is straight from your Southern Forages textbook. There are 8 of these grazing methods, and this is the first 4. And let's start at the upper left. Continuous stocking, of course, is what you would think it would be. It's where the cattle are on a given pasture without any subdivision and no rotation. The one to the right is continuous stocking with the fenced-off area during surplus growth period. And this is going to be quite common if you think about it, because a lot of Kentucky farms will have an area where in the spring that's fenced off for hay production. And then after the first cutting of hay is made, the cattle may be given access to all of it. So in a sense, you could have a very simple hay and pasture system, 2 subdivisions where hay is made on one, and then after the growth slows down, you open up the whole area and rotate them back and forth. So a very simple system, but one that works quite well. And of course, down in the bottom left, rotational stocking in the sense that we think of it, and that is where you have livestock rotating through a series of paddocks. Now, I will just say that when you have a drawing like this, it's very, very tempting if you try to implement this for the first time to think that you're going to go in this particular order, paddock, 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 and so on and so forth. Well, what is going to happen, no doubt, is that when periods of very rapid growth, some of these paddocks will get ahead. You'll have to make hay. Throughout the rest of the year, some paddocks may grow faster than others, and you may need to skip around and ping pong around this grid of 8 pastures to be able to harvest optimally. And we will not discuss it probably, at least in this lecture, but probably in others. The placement of water and the placement of alleys is going to be very important, because you're going to want to be able to have water distributed throughout this system, and you're going to want to be able to go from this, say, the upper left-hand paddock down to the lower right-hand paddock without having to cross over all the others. So that means a system of lanes and gates that are easy to use and wide enough for the cattle to get through. That's going to be very important to your system design. And the last one on this slide, the strip stocking, strip grazing. We employ this most often where we are using stockpile tall fescue. And in this case, it's not shown here, it's not specified, but in this case, I'm assuming that we're not going to back fence this at all, but we could. Now, a back fence would be that if we start here in the left-hand side and start grazing here, and we finish with this section, we drop the fence and let them go here, and then when they're through and they're grazing the new section, we put this fence up. When we stockpile tall fescue, we do not need to do the back fencing. It saves us some time because there's no forage to regrow back here. They're not going to regraze it. So they're just going to go over to where the new growth is, and it saves you some time. But strip grazing like this allocates forage as needed and really lets you gain quite a bit of efficiency. In fact, if I'm recollecting this correctly, strip grazing stockpile tall fescue and giving them the 3-day supply versus a 14-day supply would add about 42% more grazing days in that system, because they're not in the 3-day system, they're going to eat more and waste less. The next page of stocking methods or grazing methods is much less common, but you may find them referred to. Number 1 in the upper left, creep stocking or creep grazing, where you have calves or younger livestock with older livestock. Of course, the calves could make better use of, or more efficiently use good high quality forage for gain. So we have some method of having a way for the calves or the lambs or ewes or kids, or I'm sorry, the lambs or kids to go forward and go into an area either an area that's planted especially for them, very high quality, and the older animals with lower nutritional needs stay back here and they can't get through the creep gate. And of course, the younger livestock can come and go as they please. But we know that they're going to be able to convert that good forage much faster, much more efficiently into gain this way. Sequence stocking is very rarely referred to or talked about, but it's often referred to as limit grazing, where we've got highly nutritious pasture that we only give cattle access to for 1 or 2 hours a day, and then back in an area where we have low nutritional value pasture or hay. And I can think of at least an application where in the springtime, if we wind up having a very, very lush pasture and lots of clover, that we may need to limit access to this clover pasture on the left to minimize bloat. So this is a way that we would try to do that, to be able to move them back and forth into maybe a hay feeding lot or some area with less clover, and only give them a little bit of time on the clover daily. Another one is called forward stocking, where or forward grazing, or first and last stocking, where the forage is grazed off in sequence by more than one group of animals. So the second grazers takes the less nutritious forage, the first grazers take the most nutritious forage. And then forward creep stocking is just a kind of a combination of a rotational system and creep grazing, where you have a high enough temporary fence that the younger livestock can creep forward and get into the better pastures, but at the same time get back to their mamas for time with them. So forage is mathematical. So I'm going to go through at least one example and then remind you that all of these figures and calculations are present in your Southern Forage Pocket Guide. So can you figure out the forage needs of a livestock, given livestock class, based on the body weight, the percent intake, and the percent utilization? Well, of course you can. So we need to know, if you're going to calculate that, you need to know the body weight and the percent intake, which determines forage needed, and you need to know the percent of the available forage consumed, in other words, the efficiency. So that's going to be between 45 and 60% for rotational grazing systems. So for a 1,200 cow consuming 2.5% of her body weight in forage daily, that's 1,200 by 0.025, and 0.025 is 2.5% expressed as a decimal. And that's going to be 30 pounds of forage dry matter per day, or roughly 900 pounds of forage dry matter per month has got to be consumed by that 1,200-pound cow. If your system's grazing utilization efficiency is 50%, that means you've got to have on offer 1,800 pounds of forage per month, or at 900 divided by 50% as a decimal is 1,800 pounds. Continuing with that scenario, we've got 1,800 pounds per month times a 9-month grazing season, or about 16,200 pounds of forage dry matter, or roughly 8 tons of dry matter of pasture production available to that 1,200-pound cow for the year, for the grazing season. And since we know annual forage dry matter production on cool season hay and pasture is about 4 tons per acre, it takes about 2 acres of pasture to support that 1,200-pound cow. So my point is that grazing is all mathematical, based on the size of the animal, how much they're going to eat, the efficiency with which they are able to harvest the pasture, and that will then tell you a lot about your pasture system. And we're getting towards the end of this section, and that is talking about water and the 800-foot rule. This rule was actually is quite old. There's reference to things like this in some of the yearbooks of agriculture going back to the 1940s. But what people have observed is that when in the eastern or humid part of the U.S., when water is in a long way from the end of a pasture, or it's a long distance from the source of water to the end of the pasture, that livestock do not uniformly graze that pasture. In fact, they rarely get to that farthest point away from water. This rule was quantified by Jim Garish at the Forage Systems Research Center up in North Missouri. And what he found we call the 800-foot rule. And this is what it looks like. That when you have grazing cattle in large pastures, they move nutrients towards the water and the shade. In other words, they have some areas where they overgraze, they optimally graze, and they have some undergrazed areas. And what Jim measured at the University of Missouri's Forage Research Center is that beyond about 800 feet, that this pasture was not utilized. And I've observed this in Kentucky as well, even during periods of drought where livestock were no doubt limited in terms of the forage that they had. They just were not grazing this extended or this forage that's a long way, more than about 800 or 1,000 feet from their water source. So we talked about water at the beginning of the lecture, how important it is to a subdivided system, and it very much is for purposes of grazing utilization, but also when you think about nutrient movement within a pasture. In that same study, or in other studies like it at the University of Missouri, Jim Garish found that the P and K levels wound up being extremely high, close to water, that they were moderate here and that they were very low here. In other words, the nutrients were moved from the pasture area and deposited here in the area closest to the water. And of course, this is going to be overgrazed, and it's going to be a site where pigweed and cocklebur and other forages, weedy forages, will come in and encroach into your system. So to summarize this lecture, the payback from our well-managed rotational grazing system comes in three ways. Cattle eat more of what you grow. Forages grow back faster and attain the yield potential that they have. And we get greater persistence of those higher quality, more upright forages like orchard grass and alfalfa, or those those highly palatable forages like the new fescues. So this brings us to a close of the formal lectures on grazing management, but I hope to share some articles for discussion purposes a little later. Thank you very much, and until next time, we'll see you then.